So, welcome everybody to our 86th Reading Online Sports Economics Seminar. We meet again during the Winter Olympics, and it's good again to have a topical talk. We've got Vincenzo Alfano, who is going to be presenting on, when I find the title, Training and Lockdown, the Impact of Stringency Measures on the Olympic Games of Tokyo 2020. Vincenzo we've got the full hour and a half, and Vincenzo is happy to be interrupted if you have questions along the way, so raise your hand and I will interrupt him. Otherwise, we have time for Q&A at the end, so please do keep yourself on mute, but feel free to raise your hand and ask questions as Vincenzo goes along, or if you can access the chat, also stick them in the chat as well. I won't delay Vincenzo any further, so please do take away your talk, Vincenzo.
Thank you very much. Now I'm trying to put my presentation. Can you see it?
Yep.
So thank you very much again. Let me take a few seconds to thank very much Professor Reade, the organizer of this seminar series, which I am very, very honored to be part on again. Today, I am going to present you a paper we are working on, which is still a work in progress, so I hope to get very useful remarks, critique, and feedback from you. So please don't hesitate to point out what can be done better in this work. The provisory title is Training Lockdown, the Impact of Stringency Measure on the Olympic Games of Tokyo 2020, and it's a work I am doing together with Salvatore Ercolano from University of Basilicata. So this is a brief overview of what we're going to touch in this presentation. After this introduction with a small literature review, I'm going to present you the empirical strategy and the source of data, and then to comment our results, and finally to get some conclusion. So what's the main idea? Well, the 32nd edition of the Summer Olympic Games, as we all know, was supposed to be held in Tokyo, Japan in 2020. Even though Japanese, until the very last moment, try to keep the Olympic Games be done in that year, we know that due to the COVID emergency that since the first quarter of the year started changing our daily routine all over the world, they had to postpone the game to the next summer. So the basic idea is, did the COVID-19 pandemic also affected the results of the Olympic Games? There was an impact of this emergency in the Olympic Games event results. The basic idea is that all over 2020 and in the first 6 months of 2021, at different pace, different countries had different non-pharmaceutical measures, different social distancing policies that could have had an impact on the path of Olympic athletes towards the Olympic Games. As we all know, Olympic Games are the day of life, the appointment of life for many of top-tier athletes that often have training as they manage to organize their whole life around this appointment and try to arrive to the very best at the Olympic event. So, in that sense, the stringency measure, the non-pharmaceutical intervention that the state, the different governments put in place over the course of 2020 and 2021 may easily be sent in this mechanism that as a result has affected the result of this competition, influencing the daily routine of these top-tier athletes. For instance, to make some example, it's easy to imagine that non-pharmaceutical intervention may have making harder to effectively train for some athlete. Some sports need a very specific sportive infrastructure, such as pools or archery fields that may have been hard to be reached. Some sports are team sports, so it could be harder for these athletes to meet their teammates. And more in general, it could have been harder to avoid to overeat or to be in training to keep fit to the lockdown and other non-pharmaceutical intervention. In that sense, tougher non-pharmaceutical intervention may have had a detrimental effect on the chances of the national athletes, of the people who were living in these countries, to win a medal in the Olympic Games. Why is this important? Well, there are a few motivations. One of these is that we know that many nations have a lot of investment, have a lot of money going on in programs aimed to build better athletes, to compete more and better with other nations. It is a matter of prestige. Even though, according to the Boscher, there is no clear evidence that these policies have an effect in terms of international sporting success, this implementation of non-pharmaceutical intervention may represent an example of a national policy that is an important determinant of international sporting success. But of course, there is more. It matters because the pandemic is still a major threat, is still relevant worldwide, and thus estimating the impact of non-pharmaceutical intervention could help policymakers to design better policy in future, understanding better the consequences of the policies they implement. Moreover, unfortunately, there is a rich literature suggesting that epidemics and global pandemics are going to be a more and more common and relevant things in the next years. Therefore, we may get a lesson from these and learn how to cope with it in future. Finally, if this is a variable that helps to forecast the results of Olympic Games, of course, this is very relevant for a number of stakeholders, such as the betting companies, the sponsor, and more in general, the media companies, or sport politicians, I mean, the figures that manage the national sports institution, and sports managers. Saying that, this study collocates itself in the literature about forecasting sport results. It is a very rich literature. Here I've list some of the most important contributions that focus on Olympic Games. Please, you are very welcome to signal me maybe in the end of this talk if I forgot something and if you believe that there is something relevant to be added. But the most important contribution is probably the seminal paper by Bernard and Busser of 2004 that tries to find the determinants of Olympic Games success at a country level with a very long panel. There is more. There is Bayer in 2005 studying the impact of economic development on these. There are other work like Forrest et al. And Revillac about that focus about specific sides of this story. There is a very recent contribution that actually is in contradiction with some previous result that is the one of Schlemmbach et al. That using machine learning find the socioeconomic impact of Olympic medals. To the best of our knowledge, there is no contribution so far specifically focused on the issue of non-pharmaceutical intervention eventual impact on the results of Olympic Games. And so, in a way, another literature we aim to contribute is the one that studies the effect of non-pharmaceutical intervention more in general. So, what do we do? Well, basically, we relied a lot on the empirical strategy used by Bernard and Buss in their paper from 2004 and had to their strategy the operationalization of stringency measure for each country that took part in the Olympic Games, which is, of course, what makes very specific our research question and what we aim to answer. So a lot of the paper in this literature aiming to understand the determinants of Olympic success rely on panel dataset, often also very long panel dataset. Unfortunately, this is something we cannot rely upon because, of course, being focused on the impact of non-pharmaceutical intervention, this is a very specific thing that only happened in 2021 Olympic Games. So we cannot use results from previous Olympic. Therefore, we can only use a cross-sectional dataset, and panel estimation is not an option. Our numerosity, the basic unit of observation is the country, is 182. There are actually more countries that took part to the Olympic Games, but unfortunately, some of them do not have available data for stringency measures, so it's hard for us to take part in them, to include them into our analysis. Can someone confirm me that I am still online? I cannot see Professor Reade anymore. Okay, fine. Just I am worried about the quality of our internet because it's not excellent. So given that we do not suspect a strong endogeneity or any specific problem of multicollinearity between our variable, we used a simple ordinary least squared estimator, of course, Hammond that integrated with robust standard error. Once again, taking from Bernard and Buss 2004 paper, we estimate this equation where on the left-handed side we have the medals that each country won in the Olympic Games of Tokyo 2020, which is expressed as a function of the logarithm of its gross domestic product per capita, which is, as they discuss truthfully, a very important proxy of the possibility to train and to become an athlete, to have access to sport facility, and therefore an important determinant of Olympic Games success, of the logarithm of the population, that is as well an important variable according to their seminal model, since the biggest your population is, the highest the probability that someone with won the genetic lottery needed in order to be an Olympic level athlete. A dummy that identifies the host team, which in this edition is the Japanese, plus the stringency measure for each country, and of course an error term. So this is what I just said. The important thing is that our dependent variable is operationalized in a number of different ways to study the possible different impacts on different kind of events and on different types of athletes. More on these in the results section. Such as, of course, gender, the kind of sport, and so on. Data about GDP are expressed in per capita terms, of course, are before the pandemic, so there is no look behind effect, are from 2019, and are expressed in constant dollar for 2015. Population, once again from 2020, and okay, an interesting thing, maybe it's the stringency. For these, we rely on the stringency index, which is a very good index available on a day-by-day basis for a lot of countries all over the world. It's made by Halle et al. In their 2020 paper. It's the Blatavnik Schools of Government that provides it, and they basically collect data. It's a huge team made of a lot of academics and students that collects a lot of data from all over the world, and then get out with an index which is the sum of sub-indexes, but in the end they give from a minimum of 0 to a maximum of 100 a measure of the stringency in place for each country in the world, well, not for each country in the world, for a number of countries in the world, but it's a very big number on a day-by-day basis. As I said, it is not available for some basically Caribbean countries which took part in the Olympic Games and therefore are not in the same. Moreover, considering that the Olympic Games began on July 23rd, 2021, we took the mean value for each country from January the 1st in 2020 to the eve of the Olympic Games. In that way, we have an idea of the average stringency measure that each athlete had to face in his own country in the year and a half before the Olympic Games. Those are the sources, but it's nothing very exotic. So all these operations let us build a data set with 182 countries out of the 206 National Olympic Committee that took part in the pandemic. Those one, took part in the Olympic Games. Those one are all the one for which data on stringency are available. And here we have some results. As I say, the MED, which is our dependent variable, which is a measure of the success of each and any country in the Olympic Games, is operationalized in different way. In the first column, we have the total amount of medal won by each country. In the second one, it's just for individual sports, so sports in which there is just one participant, while in the last one, we have only team medals, so medals, events for which there is a team taking part into it. As we may see in the second last row, stringency has a statistical significant effect of minus 0.11 points on the total medal. So it suggests that 1 extra point of stringency on average in the year and a half before the pandemic led to a tenth of less total medal in the expedition of Tokyo 2020. This effect is not statistically significant if we only look at a sample composed by the individual sport event, the medal won in individual sports event, while it becomes more statistically significant once we look at only the team events. This is a preliminary finding that could suggest that actually stringency has had some impact on the medals won in Tokyo 2020, especially for team sports. looking at this, if we restrict the total to the gold medal, so to, of course, the most precious medal, to the winner of each competition, once again we see that there is no effect, statistically significant effect, looking at the total medals or looking at the individual gold medals, while there is a statistically significant and negative effect on the team events. Sorry, just to be more complete, the signs of the GDP per capita and the population and the odds are the positive and statistically significant. So the one we expected according to the literature, to the previous result. Now, if we focus only in the team events, if we put a magnifying glass taking into consideration only this kind of events, we can see that, as we already saw, there is a statistically significant negative effect, but in which metal it is more important? Well, this effect is stronger in the silver medals as a magnitude, but nevertheless is negative and statistically significant per all the metal. So we have a negative and statistically significant effect in gold, silver, and bronze medal won in team events in Tokyo 2020. Finally, once again, focusing on team events, if we look at the kind of events that were divided by gender, we may see that there is a negative and statistically significant effect in both the gender, but the magnitude of the one in woman team event is stronger than the one in team male event. Therefore, we may conclude that women event see a higher detrimental effect of stringency in the of an increase in the stringency measure during the pandemic from this analysis.
Vincenzo, just to quickly interrupt you, Benedict had a question in the chat, which is maybe it might be more realistic to have a Poisson distribution assumption for your regression model rather than the standard OLS model.
I don't understand which kind of estimator you suggest to use.
So the idea is that you might want to assume a Poisson distribution, so a Poisson
distribution. Yes, the problem is, yes, it's possible. Yes, to use a Poisson distribution instead of a linear yes, this is something to be. This is a thing to be done. Maybe we can discuss it later on, or there is more.
Sure. No, that's all. That's just a comment. So you can carry on.
Even because we are close to, let me just wrap it up, and then you can roast me, and I can take advantage of your critics. So, concluding from this preliminary evidence, we may see that it seems that there is an important impact of COVID-19 on the Olympic Games, other than, of course, as we all know, forcing the Olympic Games named Tokyo 2020 to be held actually in 2021. There has been an impact on the performances of the athletes due to the asymmetric and different stringency measures adopted by the different governments in the different countries. We show some preliminary evidence of this, according to whom it seems that this effect is much stronger in the events, in the sports that are team sports, that required more than one athlete to cooperate together. In the individual sports, this effect, we don't see any evidence of this effect. This idea is consistent with the hypothesis that countries with stricter non-pharmaceutical intervention put a constraint on teams that made it harder for them to train together. And so to reach the necessary chemistry and harmony that is needed to have success in such a competitive event. We should always remember that especially in the Olympic Games, even though it's such an important and prestigious event, more athletes are not so well funded and so well supported as usually professional athletes are. We are not talking about football. We are not talking about Cristiano Ronaldo here. A lot of these athletes are people that even though in a way professional, are part of the army, for instance, to be able to train so much as it is required for an Olympic athlete. And so it's very hard for them to escape national level rules that were enforced during a pandemic. It's very easy to imagine that it may have affected them. Looking at the most important medal, which is the gold one, this effect seems to be even more relevant. While if we look at the events in which women and men competed separately, so events divided by gender, the impact among the women was stronger. This is true both looking at the total amount of medals won and by restricting the analysis to the only team events. Concluding, this suggests that there has been an impact of stringency measure in the results of Tokyo 2020 Olympics, and that countries that implemented over the course of 2020 and 2021 tiger restriction has had less successful athletes. This is especially true among women and for team sports. If this is true, well, policymakers should take into account also this impact when designing their policies if they want to avoid to pay a price to the pandemic also in sport terms. Thank you very much.
Thank you very much, Vincenzo. A very short but very sweet, very interesting presentation. So we've got lots of time now for questions and comments that people may have. So please feel free to raise your hand if you have a question.
May I ask about the poison? Why it could be? I mean, this is something we can definitely try as a robustness, but why this event should be better model? This relationship should be better modeled through a poison one.
I think the idea would be that it's a count of medals, presumably. What the variable is, and therefore Poisson probably is a distribution. I think sometimes people will use the linear model like you've done because the model is still more flexible. It's easier to include fixed effects and things like that if you're just using a standard linear model. But I think in terms of the distribution, possibly Poisson or negative binomial might be.
Yes, I think that this is the thing. A negative binomial should be used instead of a Poisson because you have a lot of zero. You have a lot of countries that do not have, did not won medal. No, this is very relevant when you look at subsample team sports in women. So a negative binomial should be used instead of a possible. So yes, this is something that definitely I should try. This is a great idea. Thank you.
Thanks. Vincenzo, Ben has got his hand up.
Thank you. Interesting presentation. I have a couple of points. Let me start with the next-in model. I would even suggest to estimate a zero inflated model because the zeros clearly dominate all other outcomes. And then a couple of additional points. When you talk about stringency measures in a particular country, you implicitly assume that the athletes stay at home to train. But when you look at, let's say, long distance runners, most elite runners live and train at high altitude in some places. Seiser Alm, it's a high altitude plateau in northern Italy, and you have dozens of elite runners spending the entire year there because they can train at a particular altitude at constant temperatures. And when you look at triathletes, most of the world class either lives in Santa Barbara or at the island of Lanzarote, where they can train all year long under stable conditions. And this means they are not affected by the stringency measures in their home country to the same extent than athletes who stay at home. So that's one point. And these stringency measures are likely not to be time invariant, so they go up and down. How can you address that issue? And then finally, that's perhaps the most trivial question. What is a team? When you think in terms of track and field, 4 times 100 relay teams, 4 times 400 relay teams. This is similar to football or basketball or field hockey. Are these included in your definition of team or not? That's it.
Should I answer, or do you want to gather a few? I would prefer to answer since I already am starting forgetting the first one, so yeah, maybe it's better. So thank you very much. Those are all very relevant comments. Let's try to start with the first one. So athletes that do not live in their nation, Olympic Committee nation country. Yes, this is a potential problem. I think we can write a caveat about it, but I think it's very hard to deal with it in a quantitative way because it would require a lot of information which are hardly accessible, such as the place in which athlete wins. We have had a nice story according to this, which is even more relevant than what you were saying, which is according monetary rewards. The Italian athlete who won the 100 meters in the last Olympic game is actually living in the US since a long time because he probably gets better financial rewards there rather than in Italy. So yes, it's true what you say, but on the other hand, there is not much we can do. What we can do is to look at some general descriptive statistic about the vast amount of athletes, looking if the vast majority of them lives in the country they hold the passport and they compete for. But yes, it's a potential problem, I admit it, but I don't see really a way to fix it in the quantitative model. Then there was, I told you, I am horrible with my short-term memory. There was an issue about, can you remind me, can you help me?
Yeah, what do you consider a team sport?
The team, yes. This is related, this is a very relevant question, and we just used the definition of the official database, which makes a team event each time there is more than one person competing in the same team. I see your point. It's very different. For instance, even in archery, there is a team event in which you basically sum up the points of two archers. And of course, this is very different from football. You do not really need to train together in this. If you're good at getting the target, you are good on your own. There is no need of having the chemistry I was talking about. Something similar to what you were saying about running. Of course, if you do 4 people. But on the other end, our choice was to use the definition of the Olympic Games because it looks to us the only one in a way objective, because it's from the Olympic Committee. If we start making a qualitative analysis on what is a team sport and what is not, then I think it becomes very subjective, because where is the threshold? When is that more than one people competing on the same side becomes a team? This is, we took very different examples such as running or archery and football, and it's very clear. But then what happens in curling? When the two players, there is no curling because it's summer games, but just, you know, to reason, when the two person have two very different roles. So it's hard to take a side on this. You know, if you have any idea about suggesting an alternative way to measure teams, I would love to hear it, but we relied on the Olympic Committee definition in the events because we thought it was the only objective definition in a way. And on this, there is another idea we explored in our empirics, was to try to distinguish sports according to the facilities you need. You know, even during a lockdown, if you your sport is running, maybe it's easier for you to train rather than if your sport is swimming or playing hockey, in which you need a stadium, you need some facilities. But then we had to abandon this idea because once again, where is the threshold? It's easy to imagine that a marathon doesn't require as many facilities as as archery or swimming. But what about soccer? Do you just need a ball? Does it mean that you do not need any facility? Poor kids in Brazil playing in the middle of the street, athletes that really need a facility. You know, in these things it becomes very hard to find that threshold. And once again, if you have any suggestion, I would love to hear it. There was a third point that, of course, I forget, even though I took a note. It's about the zero inflated model, or was another thing?
Another issue. Stringency measures turned out not to be time invariant.
Yes, but we just took the average. This is the thing I really don't understand in your critique. I mean, we take of course they vary, and we took the daily value for all the days from January the 1st to the, I think, July 22, anyway, the day before the beginning of the Olympic Games, and we do the average. I don't see why they change, but I don't see what's the point. I mean, you have had the same amount of days to train before the Olympics, and you have faced different amount of days with different level of stringency. Maybe we could think of some weights once you get closer, imagining that in the days before the Olympic, the training matters most than 1 year before. But I'm not sure I understood this critique. I mean, of course they vary, but once you take the average, you have a pretty good idea of how stringent your country has been in the year and a half before the Olympics?
I'm not so sure. Assume you have two completely different situations. You have one country where you had the entire period with moderate restrictions.
Okay.
And on the other hand, you have a country where you had half of the time a complete lockdown, and the other half of the time everything was lifted. Mm-hmm. So that means the average is the same for the two countries. Mm-hmm. But clearly, the conditions for the athletes in these two countries are massively different.
Mm-hmm. So basically, your idea is that the mean doesn't get very well the level of stringency before. We can try some alternative way to compute the mean, but in the end, I believe that the variance due to the kind of sports is much higher than the variance due to the different level of stringency. Even because if you remove Sweden from Europe, you have very similar behavior all over it. So your idea, while I see your point and I thank you for that, I should reason more about it. But I think that in practice, you do not have this kind of behavior in the sample. You mainly have countries who have been very liberal and countries who have been less liberal, but on average, group of countries behaved in similar ways. But thank you. It's something to think about.
Thanks, Bernd. A related point just before a couple of other questions. A related point Benedict has added, which is for different sports, the calendar matters, and so the point in the year when stringency restrictions might matter. So you might want to, I guess, think about weighting the average towards the summer of 2020, perhaps when perhaps training might have been more intense, maybe. Jorge also put in the chat as well. He wrote, stricter COVID restrictions should correlate to how strong the virus was in a given country. Might the results be driven by the fact that relatively more athletes in countries with stricter COVID restrictions couldn't attend the Olympics because they had COVID or weren't able to train properly because of COVID?
If I understood well, your idea is that country with higher stringency measure has had less competitive teams in the Olympic because some of their athletes had the COVID. Yes, this is a good thing to check. I think there are statistics about it. As far as I know, I haven't read of any massive outbreak of COVID between athletes that were supposed to take part in the Olympics and did not. But it's something worth to be checked. And this is something that can easily be done because there has been huge coverage in general media about athletes, so it's easy. Thank you. It's a good thing to be checked. If you want an answer right now, I don't know if there is such an effect in place. Honestly, I don't think so because I haven't read about all these top-level athletes that couldn't take part today. But maybe it's something worth to be checked. Thank you.
Thanks, Jorge, and thanks, Vincenzo. Stefan's got his hand up.
Sorry, just unmuting. Yeah, very interesting. I wonder if there are a couple of interaction effects that you might consider here. One is, one would have thought the ability to adapt would be related to national wealth. So I wonder if there's a GDP per capita interaction effect here that you could consider. Richer countries can probably adapt more easily than poor ones. And then the second one is whether you could just draw a distinction between indoor and outdoor sports. Presumably, restrictions had much bigger effects on indoor sports than outdoor sports, so you could see whether you get a different effect depending on whether they're indoor or outdoor.
So, thank you very much for this second remark. This is something very interesting and very relevant to be checked. Actually, we did it and there was no real difference between indoor and outdoor sports. But once again, I think the problem is the definition, you know, because you can actually train for indoor sports outdoor. Think of cycling. So you do not really need to build the muscles you need in the Olympics indoor. You may train outdoor and then compete indoor. So I think this is a huge problem in getting an effect once you have so many events of so many different sports. But yes, it's something relevant. And about the interaction, if I understood correctly, your idea is that stringency measures are harsher in poorer countries because the national federation have less resources on average to cope with this. It's something worth it. It's we never talk about it, but so I do not have an answer for you. But it's definitely something to be tried. As you say, just an interaction. Let's see if something interesting happens. So thank you very much.
Great, thanks. Stefan, any more questions and comments? That looks like a no. So thank you very much, Vincenzo. Really interesting talk on the potential impact of COVID on the Olympic Games. And obviously you'll soon have the Winter Olympics to add to your database to expand your data for trying to understand these kinds of effects. We will return next week on February the 25th, and we will move away from Olympic sports as the Winter Olympics close, and we'll move to cricket. Stefan Zamansky is going to present productivity and temperature evidence from test match cricket. So thanks once again, Vincenzo. Thanks everyone for your questions and comments. Have a great weekend, and I'll see you all next week.
Yeah, nobody will come next week.